I am Anil Kumar. Welcome to my YouTube channel. We are serving you for last 15 years, and now we have more than 16,000 absolutely free videos for you. Also explore the website for the latest developments and some test exclusive problems. In case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. The concept here is to understand the basic and build on the foundation for excellence to achieve goals. You can carve the success of your story. We can help you. Here are 6 questions, and we are going to explore how do we find the decreasing interval of a function using first derivative analysis. So you'll find the interval of decreasing for the given functions. We have taken very basic functions. Main idea here is to understand the concepts. All of them will use power rule for derivatives. Y equals to a x to the power of n is a power function whose derivative can be written as n times a x to the power of n minus 1. Correct? By analyzing this derivative, we'll find the decreasing interval for the 6 functions. You can always pause the video, answer, and then look into my suggestions. The basic concept is given to you right here. So what we'll do is to find a critical number. Now, critical number is a number for which the derivative is either 0 or it does not exist. If it does not exist, it means it could be a cusp, right? Or like an absolute function, you have a corner, right? It could be a cusp or a corner where the increasing decreasing interval may change. So the critical number we need to find first. Once we find the critical number, then you should know that critical number really divides the planes in intervals where the function is either increasing or decreasing. So to test whether it is decreasing or increasing, take a test point and test it out using interval table. So we call this as an interval test for the first derivative. So with that concept, let's begin solving questions one by one. The very first one given to us is g of x is equal to 1 minus x squared. Find the derivative. So g prime x is equal to minus 2x, correct? Now, critical number is when the derivative is equal to 0. So that means 0 equals to minus 2x, and clearly the critical number is at x equals to 0. So that gives you a point of reference. So this x equals to 0 is the critical number. It divides the whole plane into 2 parts, one x being less than 0, the other one being x greater than 0. Take a test point in these. For example, minus 1 and plus 1 could be great test points. Now, analyze the derivative, which is given to you as minus 2x. Now, if I substitute minus 1 in minus 2x, I get a positive value, correct? But if I substitute 1, I get a negative value. Now, positive value of the derivative means what? Well, positive value means increasing interval, and negative means decreasing interval. And you can also see we will have maximum value at x equals to 0. You get the idea. So that becomes, in short, a picture for you. How do we find increasing and decreasing intervals? The question is to specify the decreasing interval. So we'll say, well, the function is decreasing into interval of We could write it in different ways. We can say when x is greater than 0. Is that clear to you? So that is how we could answer the question. As you know the graph of this, and you can verify that the function actually increases from minus infinity to 0 and then decreases from 0 to infinity. Perfect. So I think that gives you the foundation. Let's begin exploring with more examples. Now the question for us is f of x equals to x to the power of 2 over 3 minus 2. Find the first derivative. So the derivative of this function is 2 by 3 x to the power of 2 by 3 minus 1. We applied the power rule, right? So that gives you 2 by 3 x to the power of minus 1 over 3, and that is 2 by 3 and cube root of x, right? Now in this case, we can clearly see that the derivative f of x does not exist for x equals to 0, right? Because we get 2 over 0, which is infinitely large, so it does not exist. But the function is continuous, right? If I substitute 0, we know f of 0 is equal to minus 2. The function indeed is continuous. Now it's a good time to test which is the increasing interval and which is the decreasing interval. Perfect. So let's do the test with the interval table. So clearly we have an interval here, and let's do the interval between x equals to 0, right? Less than and greater than. So take a test point in each interval. Minus 1 and plus 1, like last time, becomes our test points. Now clearly, if I substitute minus 1, I get this derivative, which is f prime x, equals to 2 over 3 cube root of x. Cube root will be negative, right? So what are we testing here? We are testing the derivative itself, which is 2 over 3 cube root of x. With negative, it is negative. With positive, it is positive. Now clearly, it means that the function decreases during this interval and then increases. You get the idea. So what we have here is a function whose decreasing interval is from minus infinity to 0. So our answer is that it is decreasing when x is less than 0. Correct? Some of you can actually sketch these functions just to see how do they look like. Correct? Minus 2 will push x to the power of 2 over 3 down by 2 units. At x equals to 0, we have minus 2, and the function will look like this, right? So that becomes the function f of x in this particular case. You can see it is decreasing from minus infinity to 0, and the derivative does not exist at x equals to 0. That is a critical number. So I hope with this we have taken both the cases, that when the derivative is 0, we have a critical number, and when the derivative is infinitely large or does not exist, even then we have a critical number. In both the cases, we just check each interval, whether it is positive or negative for the derivative, and that gives you the result. Perfect. Let's move on and take the next question, which is question number 3. Now we are given h of x as 3x squared minus 6x plus 2. Find the derivative of this function. So the derivative here is 6x minus 6. You could factor 6, getting x minus 1, and clearly we have h of x equals to 0 at x equals to 1. So we have a critical number, x equals to 1. Let us test. On both the sides of x equals to 1, what do we get? If x is equal to 1, our test point could be minus, or you can take 0, right? Let's say minus 2 and 2, right? Okay. Derivative to be tested is 6 times x minus 1, right? So h prime x, which is 6 times x minus 1. If I substitute a negative value, I get a negative result. If I substitute 2 here, I get a positive result. Important is just to see the sign, not the value, correct? So now sign of negative clearly indicates decreasing in this interval and increasing in the other interval. Perfect. And therefore, we do get our solution and that is that the function is decreasing when x is less than minus 2. Clear? So that is how we get our solution. I hope the concept is absolutely clear, right? Okay, let's take the next example, which is p of x equals to 1 minus x squared minus 5 by 2. I'd like you to pause the video, answer the question, and then look into suggestions. Well, in case you want to learn from me, feel free to send an email on the address given, or check our website for some free classes. That will help. Okay, let's rewrite the function p of x given to us as 1 minus. Let's write down this as x squared over 2 minus minus becomes plus 5 by 2. Now it is very easy to find the derivative, correct? So the derivative of this function is minus 2x over 2, which is uh, just minus x, correct? Now, critical number here is x equals to 0, right? At x equals to 0, the derivative is equal to 0. So, we're going to test within the interval where x is equal to less than 0 or greater than 0. Since x equals to 0 gives you a 0 here, right? So, let's take a test point plus and minus 1. Now, clearly, if I take, since the derivative is minus x, for minus, it is positive, and for plus, it is negative, right? So what is our derivative? Remember that the derivative this time is minus x. So in minus x, if I substitute minus 1, I get a positive value, perfect? And therefore, the function is increasing in the interval to the left of origin and decreasing to the right of origin. And therefore, the interval is x greater than 0 for decreasing. Is that clear to you? Simple questions so far. We have taken quadratic equations, solved them, right? Now here is question number 5, where we have a cubic equation. So let me open the bracket and then see what do we get. The function is x times x squared minus 4x plus 4. Let us open the bracket. We get x cubed minus 4x squared plus 4x. And the derivative of this function is 3x squared minus 8x plus 4. Now, can you factor this? To find the zeros, of course, 4 times 3 is 12, 6 times 2 is 12, so that helps. So we could write this as 3x squared minus 6x minus 2x plus 2 plus 4. Taking 3x common, we get x minus 2. Here we can take 2 common to get x minus 2, and therefore we have x minus 2 times 3x minus 2 as the factors. So we know the critical number now. So the critical number is at x equals to 2, right? Or 2 by 3. When each of these factors, we equate them to 0, right? If you use 3x minus 2 to 0, you get 2 by 3. And if you use x minus 2, you get x equals to 2. So we got two critical numbers at this stage, correct? So we will divide the whole plane into three parts, where one is x equals to 2, the other one 2 by 3, right? So let's write this as 2 by 3. This is 2. Take a test point in each interval. Less than 2 by 3 could be 0, and that could be 1 and then 3. The function which we need to figure out is the derivative. So what is x minus 2? If I take a value 0, it is going to be negative, right? If I put 1, negative, 3 will give me positive for 3x minus 2. If I put 0, I get minus 2, which is negative. If I put 1, I get positive value. And there also a positive value, correct? Negative and negative gives me positive, positive, negative gives me negative, and then a positive value. That means the function is increasing, then decreasing, and increasing. So the decreasing interval is between 2 by 3 and 2, correct? So therefore, we can say it is decreasing when x is between 2 by 3 and 2. Normally, we prefer not to write greater than equal to sign. So we exclude the boundaries while we write the decreasing and increasing intervals. So make that a point, okay? So I hope this is absolutely clear. Feel free to write a comment, share your views. If you want to learn from me, send an email on the address given. Here is the very last question for you. We have a function which is rx equals to x minus 2 square root x. You can pause the video, answer the question, and then look into my suggestions. Well, the function, let's rewrite, is x minus 2 square root x. The derivative of this function is 1 minus. So 2 times this is half of x to the power minus half, which is 1 over square root x, right? Okay. So that gives you 1 minus 1 over square root x, right? So that becomes the derivative. If you want, you could write this as square root x minus 1, taking common denominator, right? Now, it is easy to see the critical numbers. So r of x is equal to 0 when square root x equals to 1, which implies x equals to 1, and r of x, the derivative, does not exist when square root of x equals to 0, right? Or x equals to 0, correct? Now, see, the domain of the function is that x can be greater than or equal to 0. So, both the points are in our domain. You get the idea. However, we're only going to check beyond x equals to 0. So, that is very, very critical. Remember this, that the domain is x equals to 0. So, now you tell me, when we make an interval table this time, how should we do it? Well, let me make an interval table. We have two critical numbers. One definitely is 0, the other one is at 1, right? So we have x equals to 0, x equals to 1. So when you take the test points, in that case, we cannot take a test point on the left side since the domain is greater than or equal to 0, right? So we can take a test point like half here and 2, right? So those are the two test points. We cannot check on the left side of 0. Perfect. And now the derivative for us is square root x minus 1. We could write it as two different factors, correct? So check both individually, right? It is easier. And then we're going to multiply them for the sign. So if I put half here, so square root, sorry, this is square root x minus 1. So square root of x minus 1 is going to be negative since square root of half is going to be less than 1. But when I substitute 2 here, in that case, also square root of 2 is more than 1, right? And therefore, that is going to be positive. When I substitute square root x itself, in that case, for half, it is going to be positive. For 1, it is going to be positive. Square root is always positive, right? As far as the derivative is concerned, is product or quotient of these. 2, 1 negative, 1 positive makes it negative, and that makes it positive. So it is decreasing and then increasing. Clear. So it is decreasing between 0 to 1, as you can see. Perfect. So our solution here is that this function is decreasing when x is greater than 0 but less than 1. Is that clear to you? Correct? Beyond 1, the function is increasing. Correct? So with that, we come to an end of this problem set where we solved all the 6 questions just with a simple concept of finding the first derivative, finding the critical number being number where the first derivative is either 0 or it does not exist. Once you find the critical number, identify the intervals, take test points, and then check whether the derivative is positive or negative. If derivative is positive, right? If derivative is greater than 0, then the function is increasing. On the other hand, if the derivative is less than 0, then the function is decreasing. You get the idea. So that helps to solve all these problems. I hope you find it interesting and useful. So you can explore more examples from our playlist. Hundreds of videos are there. We have been serving you for the last 15 years, and these are the videos which can help you perform much, much better. Thanks for your valuable time and the great comments and suggestions. Thank you and all the best.